Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all my students. Today we are going to learn about cylinders and quadric surfaces. Alright, there are two sections here. The first one is we are going to learn about the cylinders, and then the second thing we are going to learn about the quadric surfaces. Alright, let us look at our first example here. This is quite easy because we have learned it before. So our first example here, saying that identify and sketch the following surfaces, right? So as we can see here, if you still remember, this type of surfaces, we can categorize it as the cylinder, right? So for A and B, there are a slightly different characteristic. The first one, the A, as you can see here, x squared plus y squared equal to 1, the variable z is missing. Yeah. Meanwhile, for B, y squared plus z squared equal to 1, where the x variable is missing. Alright, for A, we say that the variable z is missing, correct? So it means that the cylinder is on the z axis. Something like this. Here we go. This is a cylinder and this is the x-axis. So the cylinder is about the the z-axis. I'm sorry. Right? So for B, as you can see here, the the x variable is missing. It indicates that the cylinder is about the x-axis. Here we go. Right, so this is for cylinder, right? The basic foundation of cylinder. Alright, now we go to quadric surfaces. Right, in order to learn about the quadric surfaces, we need to know about six common type of quadric surfaces. So the first one is what we call the ellipsoid surface, right? The ellipsoid surface, where this is the equation. We must know the equation first before we determine the shape of the surfaces. So first of all, we need to know the given equation, and then we can know about the sketch of the surfaces. So for this first example is ellipsoid, and of course when we need to sketch the graph, there are some important coordinates that we need to identify and find those coordinates before while we are sketching the graph. Alright, so I will explain it later. This is the first surface, what we call the ellipsoid. The second surface is this. Is this the elliptic cone, right? The elliptic cone, and this is the equation. And further up we have the third surfaces, the elliptic paraboloid. This is the basic sketch of the type 3 surfaces, and this is the equation, the basic equation. And then this is number 4, the hyperboloid of one sheet. And then this is the equation number 5. If this, right, this is number 5, this is the equation. And then the last one is the hyperbolic paraboloid, and this is the equation. Okay, so let us go to our first example to make it clear what is the information that we really need in order to sketch the graph. Now, okay, now we are given a quadric surfaces. This is the equation. So we know that we have a total of 6 types of surfaces. Now by comparing this equation of the 6 type surfaces, we will notice that the basic graph of the surfaces is this. This is the ellipsoid. The shape number 1, right? The shape number 1. All right. Besides we know the basic shape of the ellipsoid, we need to know some of the coordinates. All right. As you can see here, these are the most important coordinate that we must show, that we must plot on the sketching. So this is the first coordinate, this is the second coordinate, and this is the third coordinate. So now, as you can see here, for example, if I'm taking this point, we have 0, 3, 0, right? So now, if we know this point, we will know this point as well, which is 0 minus 3, 0. It is the reflection. Another example, if we know this point 0, 0, 2, we are also know this point as well, which is 0, 0 minus 2, which is the reflection of this point. So similar to this point, we're going to have another point on the other side of the ellipsoid, which is minus 1, 0, 0. Right? So don't talk about the reflection point, but we must know how to determine the most important point on the sketching. This is the first one, and then this is the second one, and this is the third one. So I'm going to teach you how to get these 3 points. All right. Now, by looking at this, right? By looking at this, so we know that by looking at this point here, so we know that somehow X is moving, correct? X is moving to another position, right? X is moving, but Y and Z is not moving. So that is why, for this case, in order to obtain this point, we can write down Y equal to Z equal to 0, because they are not moving anywhere. So substitute the Y and Z value into this equation, right? Substitute here, and we are getting the X value, right? Now we have 2 X values, which is X equal to plus minus 1. Therefore, we are going to obtain 2 coordinates just right over here, right? So we have this point and this point. So we know that 1, 0, 0 is exactly just right here. Meanwhile, the other point here is on the other side of the ellipsoid, which is here. Yeah, we can't see the point, but we know that it is on the other side of the ellipsoid. Okay, so similar to this, so now if you want to find this point, so ask yourself what is moving. So as you can see here, for this point, Z is moving to some position. However, the X and the Y is not moving at all. That is why we can set up X equal to Y equal to 0, substitute this value to the equation, and we are going to obtain the Z value. So similar to this, ask yourself what is moving. So the Y value is actually moved to another position. However, the Z and the X is not moving. That is why we can we can set X equal to Z equal to 0, substitute this value into this equation, and we are getting the Y value, right? So now I have already shown you how to obtain the most important point, and we eventually produce 6 points altogether. But the most important thing is these 3.1, 2, and 3. Alright, for the first example, we are having ellipsoid. I think the second example, we are having ellipsoid as well. Yes, this is another example for ellipsoid. So, different equation, but same method. Alright, same method. So, by looking at here, okay, this diagram is more detailed because it shows us all the point 1, 2, 3, 4, 5, 6, right? So but the most important thing, the most important point is this point, the point that I write in red line here, the first one here. This is the point, and then this is the point, and this is the point. So the other point is the reflection of these 3 points. So the reflection of this point gonna be this, the reflection of 0, 4, 0 is gonna be this, and the reflection of 2, 0, 0 gonna be this. Alright, so yeah, as you can see here, I've shown you how to get the point. For this point, yeah, for this point, ask yourself, what is moving? X is moving, right? X is moving, but Y and Z is not moving. So we have Y equal to Z equal to 0. Substitute to the equation, and we are obtain the X value. And further up, we are going to get the coordinate. So similar to this, yeah, these are how we get the point, and similar to this is the way we get the point. It is similar to our previous example. Alright, we go to another example. So the pattern is similar. So now we have another type of surfaces, yeah, surface, which is the hyperboloid of one sheet. So first of all, what we must do is just sketch the graph. Just sketch the graph without the point. Yeah, just sketch the basic graph without the point, and then we must identify the most important point on the sketching. Right? So as you can see here, I make it bigger for you. Right? As you can see here, the most important, the basic, the anchor point is the point that I make the red line. We have actually 4 points altogether. We have this point, we must know this point, we must know this point, and we must know this point. So other point is the reflection of these 4 points. Right? So in order to get this, so we must do some calculation. So this is if we refer to the type of the surface, this is the shape of number 4, right? Number 4. So, and this is the given equation. So now look carefully here. So for this point, yeah, we have here 1, 0, 0, correct? So for this point, the X is moving, however the Y and the Z is not moving anywhere. So that is why we have this. We have Y equal to Z equal to 0, and then substitute this value to the equation, and we are getting the X value, and we are getting the 2 coordinate just right over here. Right? This is for the first point. For the second point here, so as you can see here, the Y is moving. Yeah, the Y is moving to another position, but the X and the Z is not moving. That's why we have the X equal to Z equal to 0, and we are getting Y value, 2 Y values, and we are having the point. So this is how we get these 2 points. Alright, for this point, right, we must let Z to any numbers. Right? We must let Z to any numbers. Can we write Z equal to 3, for example? Yes, you can. So as long as they are distance, they are height, yeah, from the 0, 0 here. So we know that this from the base here to the here, we know there are certain height, but we are not given the height. Therefore, we can let Z equal to any numbers. So let us take Z equal to 2, right? So we are going to decide this point. Okay, right? We are going to decide this point. We know that let Z equal to 2 or any numbers, any possible numbers, and then ask yourself, what is moving if the point is here? Yeah, so the X is moving actually, so Y is not moving. So that is why we have y equal to 0, right? So substitute y equal to 0 and z equal to 2 into the equation, and we are getting the x values. So we are getting plus minus square root of 2. That is why we have these 2 points. One of these points is the reflection of the others. So meanwhile, for this similar method, so as you can see here, the y is moving, the x is not moving at all. That is why we have x equal to 0. Now substituting x equal to 0 and z equal to 2 into the equation, we are getting the y value. That is why we have these 2 coordinates, right? So now in this example, I have shown you all the coordinate for the for this shape. All right. Okay, we go to another example to have a look. We go to this example. This is another type of surface, which is the hyperbolic of two sheet. So by looking at this, by looking at this, we know that this is the hyperbolic of two sheet. Now first of all, make a sketching of this surface. So the sketching gonna be something like this. We have one at the upper part and one is the bottom one, so we have 2. So notice that this part is the reflection of this. So means that if we are able to obtain all these coordinates, it is easy for us to decide this coordinate. Therefore, we are going to get this. Alright, according to this, we must decide what is the most important coordinate we should know. Right, the first coordinate that we should know is this. You see here? 0, 0, 1. 0, 0, 1. This point. So the second point that we need is this coordinate, which is set 3, 0, 2. And the last coordinate gonna be this. So as long as we know these 3 coordinates, we actually know the whole coordinate of the surface. Alright, so now how to get 0, 0, 1 here? Yeah, how to get 0, 0, 1 here? So if you see carefully, at this point, at this point, z is moving to another position. So the z consists of a value which is not 0, but the x and the y is not moving at all. So that is why we can write down y equal to x equal to y equal to 0. Substitute this value to the equation, and we are getting the z value. Yeah, we are getting this point. All right, for this point, so this point, so we must let z equal to a number. So let us let z equal to 2, for example, right? Z equal to 2, and by looking at this point, what is moving? The x is moving, correct? So the x is moving actually, not the y, because the y is remain 0. So that is why we can write down y equal to 0. So we know these two information, which is y equal to 0 and z equal to 2. By substituting to the equation, we are having x values. Yeah, we're having this point. So for the last point, for this point, let z equal to 2, and then we notice that the y value is moving, right? The y value is moving, but the x value is not moving at all. So now we can write down x equal to 0, and then we know z equal to 2. Substitute this value to the equation, and we get the y values, and we get all these coordinates. So now in this calculation, I show you how to obtain this part. How to obtain this part and reflect all the point by the y-axis, about the y-axis, you are getting this coordinate. Alright, that's how we do it. Do we have any example? Yes, we have another two, I think. Okay, so let us look at this point, this example. So we are asked to sketch the graph of the elliptic cone. We are given the equation. So carefully look at the this equation. This is referred to the shape number 2. Yeah, the shape number 2, and we can quickly sketch the graph. So the graph basically is something like this. Yeah, something like this. So now when we finish sketching this graph, now the second part is to identify the point. Yeah, so in this case, if you notice that there are only two important points that we really need in order to know all the points. So the most important point is this point and this point, right? Only this point, then we are able to identify all other points. So for this point, we must do like this. We must let z equal to 1. Yeah, we must let z equal to 1, and then by looking at this graph at this point, what is moving actually? The x is moving, correct? The x is moving while the y is not moving. That is why we can write down when y equal to 0, which is not moving, so and z equal to 1, substitute this value into the equation, we are getting the x value and we are getting the coordinate, right? This is how we get this point. So similar to this, so when z equal to 1, for example, and then when x equal to 0, we are getting y value as well as the coordinate. So by using this, we are going to obtain these 2 points, make some reflection to obtain another 2 points just right over here, and then from these 4 points, make a reflection about the y-axis to obtain another 4 points at the bottom here. Alright, so overall we are able to produce all the coordinate for the given surface. Okay, our last example here, we have some simple shape. This is the elliptic paraboloid. We are given this is the elliptic paraboloid equation, which refer to the shape number 3, and then this is the sketching. Just imagine we make the sketching first before the coordinate, then we need to identify the most important point on the sketching. So this is the most important point on the sketching, which is this point and this point. So we get this point, we are getting all the coordinate basically. Alright, so similar to our previous example now, so we just assume that z equal to 1 for this point, and then the x is moving, right? The x is moving to some position that we don't know, but the y is not moving. So the y is equal to 0. Substitute this information together with z equal to 1 into the equation, and we obtain the x values and the point as well. So for this point, similar to this, and we are going to get the y value together with the coordinates. Okay guys, so I think that's for now for this subtopic. Hope you enjoyed the video. See you in the next video.